Cool. I think we're ready. So, as an impromptu launch and learn, we're going to be going over some CAD basics today. I have Inventor pulled up here. First,
what?
I was not expecting vigorous note taking.
This is for a project.
First, who here has used CAD before?
Any
CAD program. What have you used?
SolidWorks, 3D design, a little bit of
like Eagle, Multisim, Logisim, Autodesk.
Some more.
Almost all electrical.
Yeah, more electrical
Not
CAD stuff.
Never really done SolidWorks or any 3D CAD except for like my school.
Okay, I've used Altium, but I haven't used much PCB design stuff. Anybody else? Anything different than Autodesk, SolidWorks, NX? Okay. Most of them are basically the same. The user interface is a bit different. I know things like Creo and NX are a bit more text driven than drag and drop. Some aren't, but I was just going to go over some of the basics things that you'll experience and how to properly organize your workflow. I wanted to start by figuring out what we want to build. We can be creative, we can have fun. This is an engaging experience. What do we want to build? What do we want to make?
CubeCat.
I ain't got time for that.
A car. Let's build a dog.
Okay.
Model of New York City.
We're gonna do a dog. This is gonna be fun. Okay.
Should we do a cat?
No, we don't have to do everything.
We're not doing. Okay.
I am a Cats fan. Go Cats. Not University of
But if we
Kentucky.
make a dog, we can make Goddard.
We're gonna do a dog. We should make like the UK
Yes, let's do
cat.
Goddard. Yes,
Right.
let's do Goddard.
Okay.
This is what you get in democracy.
Okay. In all seriousness now, why don't we make just a simple.
Do a soda
Dog.
can.
Make it.
Okay, we'll do a soda can. Okay, we'll do a soda can. We'll do a soda can. So once we have a soda can, we're gonna make to do this efficiently. We're gonna have an assembly for a soda can.
Straw.
Well, okay, but what I'm getting at here is we're gonna have an assembly that we're gonna make. So it's gonna be made up of its parts. So you're gonna have a high level assembly that is going to be your soda can. And the first thing you want to do when any program, I don't know about electrical design stuff because I haven't done that, but at least in a physical realm, you have your soda can and you want to break it up into what parts you want to make that make up that assembly. So what are the parts of a soda can?
Tab.
So you have a pop tab. So we have, let's call this a lid.
Alright.
This is basics here. We have a pop tab, we have a lid.
A lot. Wait, when you say lid, soda cans don't have lid.
We have a top of the can, okay?
Okay.
We have a cylinder that's going to comprise the bulk of the can. And then we're going to have a bottom.
What about the label? That's separate.
That's more like a graphic.
What?
Design or like.
I'm just wondering, I don't know if you wanted to simulate the label secondly from.
Okay, you pull up MS Paint You're only allowed to use the pencil. Make a good logo. I'll check back with you in 3 weeks. But
Hold your breath.
jokes aside, does everybody understand what's going on here? Is we have a high-level assembly. So in an analogy for a CubeSat, you might have your entire satellite, and then you have your CADs of your subsystems. So you might have a power, you might have a comms, you might have your separate boards, and then an overall structure. And even that structure, if we break it down further, might have some bolts. You might have frame elements, and it goes from there, right? So the first thing you're going to do on a design is make a hierarchy of here's my assemblies, here's what I'm going to do. For complex stuff like a satellite, this is going to grow and change, which is why you need some sort of a bill of materials, some sort of a line item for your CAD, whether it's an Excel spreadsheet showing what all these are and your assemblies are. Because a soda can is easy. As Ashton put it, you have your can and the soda. We're going to make it a little bit more complicated than that, but you basically have your pop tab, your lid, your cylinder, and your bottom, right? So inside of, any questions on that, the actual organization of the structure, how it goes over to a satellite? So within your CAD program, in all CAD programs, you're going to have what's called a project. These are your projects. So I have an electrical project and machine design project here. So what a project does is it neatly organizes your assemblies and all your parts into a single repository and folder on your computer. If it's NX or something that's meant to interface with a server, it'll do that on that server on a third-party off-site where it keeps track of everything for you and assembles them into your levels. So whenever you're working on a project, we'll call this a soda can. We're going to create a new project. And it'll just be a user project, so just me right now. But we'll call it soda can. And we'll create that project. And now that project is selected. So I'm working on that project right now, and it's going into that repository. So the first thing we're going to do is we're going to create a part. And it's going to pull up a part window. So don't get confused by all of the many zillion buttons on here. But what we're going to first do is we're going to create a sketch. So the way this works is you're going to have a sketch, and then you're going to take that sketch and revolve it or extrude it to create a three-dimensional object. So you always start two-dimensionally. So we're going to go ahead and start with the cylinder of the can, right? So we're going to go ahead and select an XC plane, and we're going to make everything in all your CAD programs is going to have basically a grid coordinate system that you could snap on and off of. So we have our datum at 0, 0, and we're going to make this circle for our cylinder. So we'll go ahead and make a circle, and then we'll dimension that circle as such. So a soda can, usually you'll have actually measurements to make, but we'll say 2 inches, inch and a half. We'll say 1.5 inches. And most CAD programs, when you create a project, I didn't do this, but when you create a project, you can select whether it's in inches, metric, standard, whatever. But in either case, no matter what it is, if you want to go ahead and put in there, instead of 1.5 inches, I want 12 centimeters, it'll go ahead and automatically convert that to inches. So it is not picky about that, but we'll go back to 1.5 inches. Then we'll go ahead and offset the circle, and we'll say the distance between them, we want this can to be 1/8 of an inch thick, and then we'll hit done. So now we've finished this sketch, and you see we're back in 3D mode now, right? So I can drag it around, and a lot of them have a cube or something to represent what face you're in. So we have a top face and then a front, and then you can freely move it around. So this is, think of it as a cross-sectional area of our soda can. Now you have what's called revolve and extrude, which you're probably going to use the most. And extrusion is basically you're selecting a profile or an area and you're extruding that along a third axis that it wasn't drawn on. So we'll go ahead and make this can 2 inches long, and you could extrude it 2 inches. There are lots of things you can play around with this to get it however you want, but you can do 2 inches split evenly across each direction in one direction or another. And we can hit OK. And there we have our first beautiful little cylinder. Now, what we can do is tell the program, now that we have the cylinder, we can tell the program, okay, I want this to be aluminum 660. And it'll go ahead and define that property and say that it's made out of that material. And then where this gets really helpful is when you go in here and let's see if I can do this. And you go into iProperties. It's different for all of them, but you go into a project and you go to physical. Okay, so we haven't set anything yet, but right here you can see the density is 2.7 grams per centimeters cubed, which is that aluminum that we set it to. If we set it to brass, that would change, but we'll set it back to aluminum. And then it'll give you the mass of the object, the area, and the volume, and then it'll give you the center of gravity. Now we've drawn a perfect circle, a perfect cylinder around the origin of the coordinate system. So it's telling me right now that the center of gravity is at 0, 0, 1. So it is right in the center of that cylinder, which is what you'd expect. When you get into more complex geometries, this is where this is important, where it can compute your center of gravity. So when we take this and export it into another program, something with ANSYS or something with SOLIDWORKS or even Autodesk has their own, but when we take it and excite it at a frequency, we can see where the center of gravity is and then get a modal structure from that. So when we shake it, we know how it's going to respond based upon where the center of gravity is. For this, it's pretty easy. Now, hypothetically, let's say that we want to add to this. So you can always make more sketches onto whatever you've extruded onto another face and go from there. So we'll go ahead and say we want to take, let's see here. Let's say that we will take the 2 circles that we have and we want to cover this and round it on the top, right? So what we're going to do is we're going to draw a line. And again, you can see it snaps to that pretty easily. And we're going to take a line like that. Come on. And so now we have a bisectional line. And we can use a trim function to trim off. No, we didn't. But go ahead. Make a circle, snap to that. Trim that. So now we have this half circle that we've made on this 2-dimensional face. Does everybody see that? So now if we want to round over the top of it, we can use what's called revolve, which what revolve does is you select a surface area. Well, not a surface area, but an area. And I want that area. And we want to revolve it around that axis. And we want to revolve it for 180 degrees. Liking my profile. Oh, come on. There we go. And now we just took that half circle and rotated it 180 degrees. That makes sense to everybody. So now, if we want to make it look really weird, which of course we do, you can go back at any time. You can go back and edit these sketches. So if we edit the sketch, it'll remove that. And we have this half circle and that inner circle. So what we're going to do is we're going to make this sketch visible again. And it is hard to see, but we want to extrude that. But this time, when we extrude, we're going to do the other thing that you can do, which is cut. So if you're extruding into material that's already there, you're cutting away that material. So that's where that additive versus subtractive modeling comes into effect. You can make a block like Michelangelo and sculpt the sculpture out of it, or you can add the feet and then the legs and everything as you go. So if we were to cut this, we get a nice shape. We have made a trash can.
I'm down at bottom.
But so those are some of the functions that use a lot: cut, extrude, and revolve. Except you give it a line. If you take a circle, it gives you a perfect little example. If you take a line and a shape, and then it moves that shape along that line that you've given it. But we'll go ahead and undo that because we're making a soda can, not a trash can. Although our soda can might look pretty trashy. Anyway, if we go back and do this, we have our cylinder that we wanted to make. So we're going to go ahead and save that. So notice how it's saving in SodaCan because we've created that repository in that library. So we're going to call this the, what do we call it up on the board? We call it the cylinder of the can. Click save. And it'll save it and make a new part. What part do we want to make next? So what we're going to do here is, again, do the same thing. We got to make a circle now. We can go back and look at this CAD. Whenever you download CADs from the internet, reference them to do your calculations and stuff. A lot of programs have shortcuts where you can measure distances. So right now we're measuring the distance, and we said the can was 1.75 inches across. So we're going to make this guy 1.75 inches as well. So we're going to go ahead and again extrude it, but this time we don't want a gigantic lid. We want something very small. So there's a basic lid. Now we can get as fancy as we want with this. Usually your lid has some little curls at the end. So what we can do is we can start a sketch. Oops, I don't want to do that. Get rid of that. We're going to start a sketch, but we're going to hold and we're going to offset this guy by 1/16 of an inch. And we're going to make another circle. This is going to end up looking really badly. So we're going to go like that. Now we're going to start another sketch, which might be a bit more interesting. So what we want to do here, what I'm trying to do is we're going to use that sweep function. So we got this circle, and now we're going to create a little circle to sweep around that line there so we can get that little lip on the edge of the can. It's probably going to look terrible, but we're going to give it a try. So right now we've run into an issue here. You see how I need that circle to be on a separate plane of that sketch that I just made. So what we can do is we're going to insert a plane through there and there. I don't want that. Nope. Oh gosh. That's the one I just created. Okay. So what we want to do is we want to create a plane that's perpendicular to that. So you can see there are many planes, but we're going to want to create a plane that is tangent to a surface. I'm going to be tangent to that surface. Tangent to surface to point. So we got that surface, and it's not letting us do a point. Okay, hold on. We're going to go back, edit the sketch, and give it a line to reference. So we're going to draw a line like so, and then add a plane. Let's, oops, Oh, it wants an external point. So go back, edit this sketch. Rid of that. So if you want to, you can be very creative and you can do what's called a 3D sketch, where you can do all sorts of fancy stuff. But I am not an expert. So what I'm going to do instead, oh, stop this. Let's go back to the surface because it is being finicky. Maybe I did this wrong. I'm not the end all be all at CAD design here, but we will get through this. So I made a line there. Let's see if it'll let us put a plane off of that line. There we go. Well, hold on. There we go. So you see I just made a plane right there that is off of that line that is perpendicular. So if we rotate this, you can see that we have two planes that are intersecting each other on the screen right there. So that line that I just made to build the plane off of is what's considered a construction line. So you're creating features to build something off of. So now we can go ahead and make a 2D sketch on that plane. And we can project this geometry. So we projected that geometry as a line right there. And of that line, we'll look back at this front. And we'll go ahead and project that and that. So again, sometimes it's nice to make some construction lines here, where I'm going to go ahead and draw some lines so I can see where the edge of that cylinder is. Then I will measure there to there, 0.142 inches. So now we're going to create a circle, just a little guy on that line. And go ahead and go like that, so it touches. And then we want that distance right there. We'll come back to that. So, nope. So we want this circle to be offset the same amount as the circle that we just drew. So we're going to go back to that other sketch. Oops. Oh, we want sketch 3. And we want to see what the offset here. Offset is 0.053 inches. And then we'll go back to this sketch. Oops. And make sure that this is 0.053 inches. Okay, so we have now made this circle right here and this circle for it to travel on. So we're going to use a sweep function and we're going to select we're actually going to go, it's having some trouble. So we're going to go in here and delete these construction lines. We're going to sweep. So there we just selected the profile we're sweeping. And now we're going to select the path. I can move here is should let me select. It is not. That's a bummer. Oh. So it does not. It is not letting me select. So there we selected the path, and now we're selecting the profile. There we go. So I selected the path from the profile, and we're gonna hit OK. And it just made, now we'll go ahead and hide these work planes. So long story short, there's our pop lid. Yes, that's the next thing. So we have that lid, and now we are going to go ahead and make another 2D sketch, and we want a hole. So what we're going to do is, again, these construction lines. So I'm going to create, so we can center this, I'm going to make lines across the circle, right? Oops. Does everybody understand what I mean when I say construction lines? I might be moving. Fast. So we're basically making these lines to dimension stuff off of. So now we're going to mention this square, and we can say 0.25. We'll make this square, and we'll say, we'll try and center it. What is it doing? I'm confused. So we did not make that line very well. So now we'll dimension this from here. And it doesn't like that. Go ahead and mention this guy. Another line. You're talking about this guy? Right, but that is the dimension of the square. I want to move the square now. But nevertheless, we'll make it move things along. Okay, so we got our square. Now, let me go back to that. We want to make this semi-rounded. So we're going to go ahead and create a circle on the center line. And trim that, trim that, trim that. Okay. We have our shape that we want now. So we're going to extrude that guy. I want to cut it out. Ta-da. There's a pop can lid. So now we're going to save as and call this the lid of the can. Now, all we need to do is make a bottom. I'll make a part, and we'll just do this really quickly here. Hold on. Save that as the bottom of the can. Okay, now we have our three parts, right? Our bottom, our cylinder, and our lid. We'll get to the pop tab here in a second if we want to. So now we have those three parts and we need to assemble them. So what you do is we make a new assembly, and it's going to open up a new assembly. So instead of making stuff, you're assembling it now. You're taking your pieces, putting them next to each other, putting bolts through them and constraining them. So there's this place button, which is when you place items. The first item you place is going to be what's called grounded, which means it's fixed into the spatial coordinates. It creates the origin or 0, 0 off of that part, and everything will be anchored to that part. So we're going to make the bottom of the can. There you go. We place it, and you can place as many parts as you want. But we're only making one soda can today. So now we're going to place our cylinder, which we didn't. Now it keeps the other one open. So in this one, we did not declare it as aluminum. So we're going to save that. And we're going to say that this one is aluminum as well. Save that. And then you go back to your assembly and it automatically updates. So we've got this can lid and this bottom. So what we're going to need to do is constrain them. So constrains are mates. So we're going to do a mate here. So a mate, not just for Australians, but what you're doing is you're taking two flat surfaces and you're making it so that they have to touch each other. You're mating them together. And it gives you nice little items here. You can make them touch each other or be parallel to each other. And we want them to touch. So we are going to select our base and then select the bottom of our can. And it makes a nice little noise. So you see how they have to touch now? If I did flush, well, now those two faces have to be even with each other. So now they're mated, and I hit apply and okay, and hit apply and then exit out of that. So now I can take this and I can move it, right? But I cannot move it. If I was perfectly centered, I can't move them off of that plane. Does that make sense? So I can, they're stacked on top of each other. I can move it side to side, but I can't pull them away from each other. So now we have to constrain them again so they're right on top of each other. And what we're going to do is what's called an insert. So we're going to take, hold on. Yep, we have that made. Okay. We're going to take this insert and we're going to take that. Come on. And that guy. And now we just took those two circles that are the same size and were concentric and aligned them together. I hit OK. And now I can't move these two guys apart. I can't separate them. Does that make sense? We're actually. So you see how I can't move it now? They're physically attached. So now. Really? You made a logo for the can? I have not put a logo on anything for a long time. So we'll see if we can figure this out. But so now we have our can. So now we need to attach the lid. So we're going to place our lid. Boop. And do our mate and constraint. I'll run through these here quickly. Insert, like I said, takes them and aligns them. The two different sections are if you want them to be flush or inside of each other. So if you have a hole in a peg, sometimes you want the peg to be just outside the hole. Sometimes you want it to be aligned so it's inside the hole. That's how you're constraining them. Tangent is just what it says. Inside or outside, you're taking two faces and making them tangent to each other so they can roll, but they have to touch. And then this is defining them as an angle if you have a hinge or something like that. So they're attached at a common vertice. But to continue with the pop can example, we're going to go ahead and attach them. People are going to be really confused when they watch this on YouTube and they just hear me go boop. But now we can go ahead and align those. So as you can see, we've constrained it so they touch, and we've constrained it so that both the outer perimeters have to be aligned. And you couldn't see this on the bottom, but it can still move. It still has 1 degree of freedom. You can still take this and rotate it, right? Because it's not validating those constraints. They're still touching and they're still aligned with their perimeters. Does that make sense? And so this is how you can, if you really want to get fancy in CAD, you can make it so you have gears that mesh and can rotate and stuff like that. That makes sense. So there's our soda can, our beautiful aluminum soda can. Now, so now we can make our lid. So we have our base can. So you can have base and high level assembly. So what we're going to do is we're going to save this assembly, and this is the base can. And here we have an assembly. So now we're going to go back and make a new part. And we're going to make our pop tab. I hope you go ahead and mention this. It's a pop tab. Now we want to round it off. So what you can do to round it, there's the center. Depending on how you want to do this. Yeah, we'll go like that. So you see how I put a circle inside the square? You can either do what I did before and add the circle externally, or we can go like this, right? And I want, okay. Trim. You're killing me, Smalls. Okay, so it doesn't want to trim this right now because it would invalidate the dimension that I preset, right? Because it has a split dimension. So we're not going to worry about that right now. Oops. But trim that, trim that. Delete our dimensions. Now I've gone through and made that end rounded. And so that'll be this will be the bottom of the tab. This will be the top. This will be the bottom. This will be the top. And we'll go ahead. So the other thing you can do, just to show the different ways, because there's no right way to do anything in CAD, but you can make a fillet. So you're putting in a radius for a circle, and then what you're going to do is select these two, and you can see it goes ahead and defines it and rounds it off like so. So there's a pop tab. You can extrude it. That does not look pop tab like.
There's a couple holes in there.
We'll get there. It's a little thick right now. You're done.
So
Anyway, so once you make an extrusion, you can go back and edit it. So we want this, let's say 0.02. So there's a pop tab. Grace said we should put some holes in it. Go ahead and quickly put some holes in it, and then we'll extrude again and select both of those. Cut away. Cool, we have a pop tab. I'm going to save as and save it as the tab. So now, what makes CAD nice is you might have on your CubeSat, you might have a sub-assembly for your comm system. So you have a PCB board with all your components on it, and that's an assembly. You can make as many high-level assemblies as you want. So we're going to make an assembly, and it's going to have the pop tab and your logo on it. So what we're going to do is we're going to place an entire assembly to start off with. So we just placed an assembly in an assembly. So that's what's called a lower level assembly, and this is a higher level assembly. So eventually in your CubeSat, that thing that you wrote at the top, which is a satellite, or in this example, a soda can, that is your highest level assembly that has everything else in it. But however you dictate to organize it, it might be helpful if I tell Ashton, who's in charge of the structures, to make an assembly of the entire structure of the satellite, and then I make an assembly of the entire payload structure. So instead of adding 3,000 parts to his assembly, we just add 2 assemblies together. And so it helps with workflow and stuff like that, which is why it's important to manage what assemblies you have and who's working on them, right? And you have those standards. I know, Jessica, you've been talking about creating some sort of CAD standard, right? Because if Ashton makes his in metric and I make mine in English and our standards don't align, we're going to have a fun time trying to assemble the satellite on the computer. But anyway, we have our pop tab. STL, which is a stereolithography file, and it takes your part. If you have, think back to your calculus days, if you have a can, you can slice that can into a bunch of little slices, right? 10,000, 30,000 format that goes into a 3D printer, right? So you've basically taken your CAD file and sliced it into all those little passes that the printer has to do. Right, so that's how you can export it to use it in all your different systems. You can just save it as and export it like that. Does anybody have any other questions? We can see what. What did Ashton send me? Oh, you're too kind.
It kind of looks like the Earth.
Yeah, I was gonna say, it's supposed to be Earth or leopards.
Yeah, it's supposed to be there.
So go ahead.
Yeah, I'm playing ahead.
The mascot.
Mascot.
We put that on all of our official documentation.
I want this on a t-shirt.
So we'll save this.
We use this as a watermark.
So this will be. This will be cat. Now, inside of an assembly, you can still do modeling. Okay, so you can edit it at the assembly level, right? So you don't have to always go back in. So if we want, we can assign a plane. I can see if I can do this. I haven't put, I took a CAD course in sophomore of high school, and that was the last time I put text on a CAD. You're really stretching me thin, Ashton.
Sorry. It's a learning
Tangent to surface through edge. We don't have edges. It's not edgy enough.
I can make it edgier if you want it.
I'll pass. But basically what you do is you can establish a plane that's on the face of the soda can and attach an image to it and then tell it to wrap that image around. It's a lot easier if you have a flat surface. So this was a satellite and you wanted to put a little sponsor on the satellite. What you can also do a lot of times is if you have a text and you have an image, you can stamp it in your CAD. So if you take that, it'll recognize the lettering and the enclosure as symbols, and then you can cut that into whatever it is you're doing. Just as a quick side note, what I'm talking about here, this is other CAD work that I've done, but you can also, if you look on this image, right, this was all done in CAD, but what you do for a CNC machine is you take your CAD design and you have faces and you export that to a DWG format or a drawing format, and that creates your tool paths, right? So when we start manufacturing our satellite and we have a CAD design, all of the manufacturing that we do, and even when you go out into industry, it used to be, drafters sitting on their stools with their pen and paper, and then you go through and you make a wood casting, and that's not the way it's done anymore. These days, you have your CAD program and you create your toolpath from that, and then you make it. It's pretty straightforward. So that's why this CAD is important. That's why your requirements are important. Because again, if your standards that you made the CAD with don't align with that machine that you're drilling this with, if your precision is off, if you have stuff that's as precise as 3/1000 or 3/1000 of an inch, and your jig or your auto router or auto lathe can't do that, you're not going to get that precision, right? So you have to be aware of what's making your product as you design it and stuff like that. Yeah, Ashton.
I looked up about putting, images on cylinders, and one of the other things that was mentioned was that it's got to be constrained to either a BMP, a doc, or an XLS file format. So that's the thing.
Right. You can save as a BMP. So like, here's a good example. Here's a gearbox that was designed, right? So you can get as intricate as you want with gears and stuff like that in your assembly. And then that's what it came out as. So if you do it right, your finished product should look exactly like your CAD. It just takes many hours, but it's worth it. Does anybody have any other questions related to CAD software or a wonderful pop can? UC now through CAS has licenses for NX for everybody to use. So if you are a CEAS student, you can get NX and CAD software for free. Autodesk you can get for free as well. If you look up Autodesk Inventor, as long as you have a .edu address, you can get all this software for free. You can play around with it, do whatever you want. Same with NX now through CEAS. Grace?
Get any of those on a Mac?
No.
Yeah, Inventor.
You have parallels, though.
You can run emulator software or parallels on a computer to simulate Windows and then run it on Windows. But the only software that runs on a Mac is Inventor Fusion. And that's rough.
I've heard.
It's like, it's a little better than Google SketchUp. A little bit.
You have an extra Mac, but it is also very rough. Okay, noted.
Yes. Windows, all CAD software basically runs on Windows. Not
Have you used
even,
Parallels?
not,
Have you used Parallels before?
No.
Super nice. It's just like you can run Windows in like a separate, like in its own window, like on your Mac. So you don't have to like, it's not like Boot Camp where you have to reboot it.
yeah.
You can just run it alongside Windows. It's
No,
like
it's
$40.
that- Oh, it's fine.
Yeah.
If you have Boot Camp on your Mac, you can run this with that partition.
Yeah, I just don't have enough room on my partition anymore is the problem, but
Yeah.
I can finagle.
Also, CAD software, as you get more advanced, does require some computer oomph. At a minimum, I'd say you'd want 8 gig of RAM to be able to do it easily and efficiently. 8 gig should be plenty. You might be able to scratch through with 4, but a lot
It's
of
2018. You should have 8 gigs of RAM nowadays.
you should have 8 gigs of RAM nowadays.
In Slack, Jessica, she put in the NX, the free NX link.
Yes.
in Slack. And then I just found the CAS like list of all of the laptops